Imagine if you could monitor exactly when the coronavirus started to spread. Imagine how much more efficiently that would allow you to stop its spread by staying indoors. Now imagine the exact same situation but in plants. Hi everyone, my name is Anastasia. I'm a plant doctor, also known as a plant pathologist. My work centers around protecting your crops like peas, blueberries, and cherries from diseases. I work on developing early diagnostic techniques, which means I can tell you if a plant is infected before you even see visible symptoms. If you have hay fever, you might actually know quite a lot on this work already. The technology I'm trying to improve is similar to the technology that tells you if you will start sneezing and crying soon because of the pollen in the air. The technology works using machinery similar to this hoover to suck up stuff out of the air. When we examine the air samples, we see that the air that we collect contains dirt and poop. We see that the air that we collect contains insect parts, pollen, and fungal spores. These will make your crops ill. If the fungal spores find their targets, they can potentially lead to the death of plants if they are left untreated. Depending on how much air passes through our hoovers in a day or a couple of hours, we can estimate how many fungal spores are in the air and if they are infectious to the crops. This will allow us to issue a high-risk alert or not. If it is a high-risk alert, we would like to advise the plants to run indoors. Of course, they cannot do that. So we do the next best thing and let their growers know to apply fungicide to stop the spread of the infection. This way of monitoring, especially in real time, requires quite a lot of time and manual labor. Plant pathologists do it with a microscope. Crouched, strained, sweating, looking through a tiny hole to find the spores of interest out of millions of other spores, pollen, insect parts, poop, and dirt in their samples. So it is impossible to do it for all pathogens and around the world. The process is just too slow. However, there is a solution. We are working on molecular techniques that operate based on the unique DNA code of each living thing. With these techniques, all we need to do is add specific liquid to the air sample, heat it, wait 20 minutes, and voila! We have our results. Knowledge about what spores are in the air and in what quantity. Knowledge about whether to apply fungicide or not. This is what will make real-time monitoring an easier and cheaper task to perform. All that straining and sweating over a microscope? Gone. This will hopefully let us employ and monitor more locations, be of more use to our farmers, and protect our environment. So in short, I guess